All right. Today we are going to learn about version control with Git and GitHub. So why does this matter? Why do we care about this? Version control software is super important for software engineering. Just like how with the Google Doc, you can see the changes that have happened to it over time. It's what lets us keep track of the changes to the code we write. So as my programs get big and I might have dozens or hundreds of files and maybe thousands of lines of code, being able to see the history of that entire code base or project and work with that history, go back to a previous version of it is really important. It also lets us collaborate on the same code base safely and efficiently without causing problems or what are called conflicts. And that's really important too, because software development is a team sport. There are a bunch of different version control softwares out there. Mercurial is one of them. Git has become extremely popular and has become sort of industry standard. And that's why knowledge of this is really important and why we introduce it early in the course. Git was created by Linus Torvalds, who also created Linux, the open source version of Unix. And in fact, it was created specifically to help manage the challenges of a remote distributed team. It's extremely widely used, especially in the open source community. So today we're going to learn about Git fundamentals, and then we're also going to learn about GitHub fundamentals, and we'll talk about the difference between the two. You'll learn about cloning a GitHub repository to make a local copy and doing work, how to connect a local Git repo to a remote one. Once you've made changes to your code on your computer, it's called pushing those changes to a remote Git repository on the internet. And especially if you're collaborating people, learning how to, it's called pull those changes. So if my teammate has done some work and they've pushed it to a GitHub server for a repository, I can pull those changes to get that work. We're going to learn the fundamentals of Git workflow, some really helpful tools called status, like Git status. We're going to get comfortable with the command line. And while we won't need it right away, we are going to learn a little bit about what's called a Git branch. Do folks have any questions before we dive on into the lesson proper? All right, let's do this. And could I please get a volunteer to read this section here? What is Git?
I can read it.
Go ahead.
Thank you.
What is Git? Git is a just another command line tool slash program, the same as Mictor or Python, but a uniquely important one for doing professional software development. Git is the de facto version control system for source code. If you ever save some changes to a file and just realized a few hours later you deleted something you now want to recover, Git is how software developers manage their code changes so that the history of the project is tracked. As a result, we can never completely lose any of our work. Even if we outright delete something, we can always rewind to an earlier point in the project's history to recover it.
Thank you. I was muted. Thank you. Let's take a big picture view real quick before we dive into nuts and bolts. And let's look at a GitHub repository, actually, that holds this curriculum. So I know many folks have seen this. For folks who haven't, a repository or repo basically holds a project and it can hold a number of different files. It doesn't care if those files are Python files, JavaScript files, text files in Markdown format, or anything else. GitHub is a platform for looking at Git repositories on the internet in a nice way and collaborating with other developers. So it does nice things like it shows a README file, and we can have links to different parts here, but we can see all of these different files. And then, I could look inside here, and there's more files and so on. So we can see the current state of the project, but where it starts to get interesting is if I go here to click on commits, and we'll talk in a minute more about what commits are. But here I can see the history of the project, and I can see all of the changes that have been made. And so I can see here specifically that on this date, this one file was created, right? And this content was added. And so you can see changes to an individual file, new files being created, changes across multiple files, and so on. So that's just a little bit of a big picture overview of where we can end up with Git, where whether it is curriculum in markdown files or code, we have this really granular control over our application. So let me talk a little bit about Git versus GitHub. Um, I mentioned this briefly, but they are two different things. So Git, which we'll be using on the command line in just a minute, is a software program. Can everyone see my terminal okay? Awesome. So Git is a software program, and I use this to create Git repositories, to add code to them, to manipulate that code, and so on. We use Git to manage changes to a project that lives on my computer. You'll hear your computer or my computer being called the local development environment or a local machine or the local developer environment, as opposed to, say, a remote environment like a server in the cloud. So local means your own computer. And so that's usually when we're using Git on the command line like this. In order to collaborate, GitHub is a company now owned by Microsoft. They acquired them that basically runs Git on servers in the cloud and gives us that really nice user interface over it that we saw. And this is where we can back up our local Git repos. So we can back up our projects and it lets us share them with other people. This is really valuable. I always, whenever I'm writing code, I'm always making sure I am tracking all my changes in Git and sending them to GitHub, because if anything happens to my laptop, this way the copy of that work is saved, which if we're a business is incredibly important. It's also incredibly useful for collaborating with others, and it's the standard of how software engineers collaborate and work with code. Whether you're a remote team or in the same room, everyone is using Git and GitHub regardless. That's outside the scope of this lesson, but it will get covered later in the course. So we have just a nice little diagram here where we can see I've got my local machine and then a GitHub server in the cloud. And so I might be working on code here. Maybe there's some image files and a resources directory. And then when I'm ready, I sync or push that code to the cloud. And then, maybe a teammate of mine wants to grab the changes I made to this file and these image assets. So they would then pull down those changes from the GitHub server on their cloud onto their own laptop. And we'll get part 2 of the lecture, we'll get deeper into GitHub. For part 1, we're just going to focus on Git and the command line. And I just want to pause and check in and see if folks have any questions. Okay, cool. So I'm going to leave some of this here as we go, but I'm also going to be doing some drawing. Alex, yes, sir.
So how is how are we gonna save how does a computer save a repo that you pulled from GitHub? Is it just gonna choose randomly where to put it?
That, that's a great question. Yeah, we'll see that in action a bit later. The short answer is we tell it where to put it, and it all gets saved as files in our file system.
Cool.
Yeah, good question. Thank you. What else are people curious about? What else is on people's minds? All right, oh, Tom, yes, sir.
Before we do a git init, I know I'm jumping ahead a little bit, but before we do git init on our local system, do we need to have a repository set up on GitHub, or can that be done later? I'm assuming later because obviously we're not doing it now, but best practice wise.
Yeah, that's a great question. It can be done later. That's what we're going to see now. In terms of best practice, you usually create the GitHub repository first and copy it onto your local machine. But for the purposes of learning and getting comfortable with Git, we're going to create it from the command line. Yeah, great question. All right, and in fact, let's go ahead and do this now. So I'm going to create a directory named my first repo. And Git repo or repository, I'm just going to call it repo. It's really a directory at the end of the day, and it always lives inside a directory. And I'm going to use my favorite friend print working directory, pwd, to see where I am. And we can see that I don't see any files in here. It's an empty directory. I just created it. And with ls-a, I can see that I don't even have any hidden files. So now let's turn this directory into a Git repository. And the command we use is git init, and init is short for initialize. And we see this statement saying, hey, we made an empty Git repository. And now if I run ls-a, we see there's a directory, a hidden directory named .git. In fact, if we look inside it, we see there's a whole bunch of stuff in there. This is much more advanced. There is a future workshop that will dig into this a bit deeper. Right now, the two important things to know about this .git directory are this is what makes the my first repo directory a Git repo. If I delete it, it is no longer a repo. And then the other thing to know, and I'm using the up arrow to navigate through my command history here, is you should never, ever have to modify the .git directory or anything inside it. And you should never, ever really delete it. If you ever get to any of those points where you think you may be doing that, reach out to a TA or an instructor, because almost definitely something has gone wrong. So now that I've created a Git repository, my command line prompt has also changed. The shell tells me that I'm in a Git repository, and it tells me the name of the Git branch here, which is main, which is the default branch. And we'll talk more about branches in just a little bit. So just the same way that using pwd and ls to keep yourself oriented on the command line is really important, Git status is your best friend in working with Git on the command line. And you should and will be typing and running this all the time. I type git status after almost every single Git command I do to make sure I'm keeping track of what's going on. And we can see that it's given us a bit of information here. Let me grab our annotator tool, and we can see it's saying what branch we're on and that there are no commits to this repository yet. And we'll talk about commits in a minute. And I see we have a couple questions. Arnold, yes, sir.
Yeah, so I did it last night, the Git init, and instead of main, it says master. Is there a difference on that one?
There's no difference. The naming convention changed from master to main depending on what version of the software you have. It'll use one or the other. Yeah, it's called the default branch, and the main thing is just knowing which one the default branch is. Yeah, great question. Alex, yes, sir.
So I actually initialized the wrong repo or the wrong directory. Is there any way to exit?
So if your Git repository is empty and you realize that you don't want it, you totally can just delete the Git repository. Note, by the way, let me navigate up a directory. right? Right now, I'm in my first repo. Let me do cd space dot dot to move up a directory into intro git. Note that this message went away on the command prompt. My shell, my terminal looks for that .git directory that indicates a repo, and when it's not there, the command prompt changes. And if I navigate back in, we see it come back, right? So I don't have to do anything here. And really, again, this Git repository is just living in our file system. Because Git is such a common tool, the shell just gives us some useful information on the command prompt. Now, if I'm certain that I don't need to worry about like the history of anything in a Git repository, if I've created one that I just want to get rid of, if I just delete that .git directory, then the repository is destroyed. Just, I would make sure that there's nothing there that you want, though it won't actually delete files, but you will lose all the history. And then again, to recreate it, I just do git init. Does that help answer your question?
Yes, I accidentally initiated in the intro git instead of
Mhm.
my first repo.
Got it. Got it. Yeah, you can just delete that then with rm-rf. Tom, yes, sir.
Just to piggyback off of a previous question, the difference between the main and master, I know once again, well, I know we'll cover this later, but since it was already asked, I know that GitHub uses a different naming convention for their master branching. Does that affect our local Git naming convention for like changing the name? Because I know they have to like sync up in order to sync properly for that. So I know we have to do some weird name changing. Maybe that's what he might be talking about. So is that what we actually do with that initialization command from GitHub is by changing that name?
That's a great question. You will not have to do that, is the short answer. If I create a repository on GitHub and then I clone it onto my computer, which we'll see in part 2 of the lesson, then whatever the default branch's name is on GitHub, which is main, because that's now the standard, it will already be set up that way on my computer. Yeah, good question.
Okay, I was
Uh,
just verifying because I know going through the foundations, we had to just for practice, we did some stuff to where we purposefully did not create like a README and stuff like that. And then when we set it up locally, we had to copy and paste some boilerplate that it gave us to where we had to change it from like master to main or main to master. Um, just in order to sync up the naming convention or whatever. So
you
that way
guys
we
should
could
not have
actually
to do
do.
that. You
Hmm,
guys should not have to do that regularly. That's going to be the exception to the rule if it happens at all.
gotcha. Okay.
Yeah. Bryson, yes, sir.
Yeah, just real quick, are you wanting us to follow along with you on this, or are we just allowed to just take notes?
I think taking notes is the better way to go.
Okay,
If you want to code along, you can, but we we don't move. We're not going to kind of slow the pace for people to code along. So it's
that's what
sort
I
of
was
do at your
thinking.
own
Because
risk.
yeah, I tried it yesterday and it was kind of overwhelming. So I was just wondering if
Yeah.
I could. Okay,
Yeah. And I actually think taking paper notes is better because it lets you focus a little more, I think, on concepts. And there's all these studies that show that writing stuff down on paper kind of reinforces stuff.
sweet.
Um,
Thank you.
yeah. Over the weekend, I do recommend trying to kind of maybe get a day ahead and looking at like previous lessons a bit in advance. But yeah, take notes. Arnold, yes, sir.
So just to verify for the RM and RMRF, so so it's better to use RM tag RF when deleting a repo?
Got it. Yeah, that's a great question. So this dot git is a directory. Right, if I do ls-a, and if I do ls.git, I see there's a bunch of files and other directories inside here. And whenever I need to delete a directory on the command line, no matter what it is, I can't just use rm. That deletes a file just fine, but it won't delete the things inside a directory. So I need to add the flag recursive that tells the remove command that there's other things inside this directory, and there might be folders inside folders inside folders. And don't prompt me like to double check every single thing, just delete it all. And so this is the standard command for deleting any directory, really. Yeah, great question. Thank you. Tony, yes, and then I do want to move on.
It might be a bad question, but I'm stuck on that default profile. I don't know how to get out of it. Or should I be
Why
working
don't
on
you
it?
show me when we take a break, especially
Okay.
because as I said, we really don't recommend coding along.
Possibly type deactivate.
Eight.
Yeah, the Python virtual environment isn't going to impact anything related to Git. Yeah, again, guys, coding along is really at your own risk, and I don't recommend it. Tony, I'm happy to take a look, but I just need to do so during a break. Cool. Yeah, no, guys, these are great questions, and this is exactly what we're here for. So keep them coming. You know, if I want us to move along to make sure we cover stuff, I'll let you know, but please like never hesitate to ask. And I can pretty much guarantee, in my experience, you know, in 3 years at Platoon, every question that someone has is on at least 2 or 3 other people's minds. So thank you. All right, so we've created a Git repository, we've initialized it, we've seen that that init command just creates this .git directory. And I was talking a little bit about git status. And this command is your best friend. And it says here, it gives us kind of a hint of what we should be doing, which is, hey, let's make some files, right? So let's make a couple files here, and then we'll use this add command to start adding files to our repository. And by doing that, we'll really learn what a commit is. And in essence, a commit is a change to the project that Git is aware of, right? And so for this project, I want everything to live inside this directory. And this Git repo I've created, I can use to track and manage all the files I create inside this directory. Anything outside this directory is by definition not going to be tracked or handled by the repo. So let's make a couple files. And I'm going to use the VS Code command line code. And this will create and open up a couple files. Let's actually just do touch. Let's do touch example.txt. Touch is the command line command that will just create an empty file. And I can see now I have some files here. And let's open these up. And if I hit tab, it sort of auto completes for me. And so I have these 3 empty files. And now let's type git status. And now we see something interesting. I'm still on branch main. It still says no commits yet. The repository isn't really tracking or protecting anything, but it knows that files exist and it's telling me that I'm not tracking them. So this Git repository is saying, hey, there's some changes you've made here. I'm not tracking them or protecting them in the history, but I'm aware they exist. And if you want me to start tracking them, if you want me to add them, let me know. Right? And this actually kind of gets to the heart of how Git works. And let me give us a little more real estate here. and just give me a moment here to put together a diagram that we can use to keep track of our files. So everything inside a Git repository is in one of three states: untracked, added, or committed. And we'll kind of shrink that up so it fits there. And this is probably the most important concept in Git. And the way I like to think about this is like, I think of it sort of like maybe baking cookies. When you add a change, it's like adding a cookie to the baking tray. But when you commit, all the cookies on the baking tray get put in the oven and cooked, right? And once the cookies are cooked, they're committed. They are cookies. Like if the cookie's too big, if the cookie's too small, you know, the cookie officially exists, right? And I think these bullet points are probably a little counterproductive, so we're just gonna get rid of them. And untracked, it's like, you know, the cookie dough, you know, the cookie batter is in the bowl, right? It's not even on the baking tray. So right now we have a couple untracked files, right? And thank you for bearing with me here as I just get our diagram set up that we're going to use for the next several kind of iterations as we look at things. We have our JavaScript file. We have our Python file. And we have our markdown text file. And the git status command shows me the status of my Git repository. It tells me what's untracked, what's been added. It doesn't tell me what's committed because then the cookies are already baked. So I can see here I have these three untracked files. And if I want to add a file, and let's just go ahead and add the JavaScript file. Right? That file is added. We also call this staged. So you'll hear it called staged or added. So we have untracked, staged, as sort of in like backstage or staged and ready to go, and committed. And now if I type git status, and let's actually clear the terminal and do it again. Still got our branch name. There's still no commits, but there's a change that's staged or added and it's ready to be committed, right? There's a cookie on the baking tray. And it tells me a command I can use if I want to unstage it, if I change my mind, and then these files are still untracked. Git provides a little bit of protection to a staged or modified file. Untracked files, it doesn't give a lot of protection to. Once something becomes committed, Git has saved it in its history, so I can always find it and get it. It can be a bit of a pain to add files one by one, right? If we were to do git example py, example txt, especially in terms of your coding workflow. And so a lot of the times we will just use the dot operator, which says add all the untracked changes in this directory. So this is probably the command that you'll use the most, is simply git add dot. And now if I type git status, and this is why git status is your best friend and you should be typing it all the time, we see that all of these new files are staged. Now, once they're staged, I can commit them. I can actually bake the cookies, and now Git will actually start saving a history here. If I type git commit just by itself, a commit message has opened as a text editor window in VS Code, because in InstallFest, we configured Git to use VS Code for commit messages. Note that these lines are commented out. I could add a message here. I could say, my first commit. I am actually going to cancel this commit. I can just close this text editor window and let's just say don't save. If I type git status, everything is still added. None of that's unchanged. It just did not do the commit. And the reason I did that is because there's an easier way to add a commit message. I can do git commit and I can add the -m for message flag. And I can just say here in quotes, my first commit. And this is a whole lot easier, and I recommend doing this most of the time. And now our work is committed, right? These cookies are baked. They really exist. And if I type git status, it says nothing to commit, working tree clean. Working tree is a fancy name for this directory, and it's looking at anything untracked or added, and there's nothing untracked or added. So the working tree is clean. Now let's type git log. And now we see something interesting. We have some history here. I see what's called a commit hash, which is a number that uniquely identifies the commit. I see my commit message. I see the date, which was automatically generated. And based on my Git user information, the person who wrote the commit and their email. So Git keeps a history of all of these things. And in fact, this is a little fancier, but if I use this tool called diff, which is short for difference, oh, we can't use it quite yet. But let's see here. Let's bring up the sidebar. So there are a couple sidebars here. There is one for Git. We don't recommend you use it. It's called source control, as in source code, which is the same as version control. You can see, I think I have an extension installed, but you can see the history of commits. And if you click on this, you could actually see if there were changes to the file, you could see different files. And as we add more commits, we'll see this graph grow. That said, I think the command line is really the way to get comfortable with Git, because it's important to build up that mental model. So again, this is really our workflow. And just to kind of show this workflow in action again, let's go ahead and modify some of these files. And in example txt, let's just say hello world. And now if I type git status, we see that in fact Git is tracking not just when we add a new file, but if we change a file. And so we have an unstaged change. And let's grab our text file. And just to kind of illustrate this, I'm just going to put in here a message, like just, I'm not going to try and type out like hello world. I think that would be a bit too much, but we have the change itself, right? It could be 1 line of code. It could be 20 lines of code, but we have the actual change here. And I can go ahead and add that change. And we see now that this change to this file has been added. Let's go ahead and let's modify our example py file as well. And now if I type git status, I see that I have a change added or staged and a change that's not tracked. Right? And if I committed this change, it's only going to commit what's staged over here. And let's in fact do that right now. I will say commit with a message, and let's just say example txt add hello world. And if I type git log, we now see that the commit history has 2 commits, right? This has now been committed and sort of like added to the mix. And in fact, what ends up happening is as we add more commits, we end up with a sort of like almost like a graph. And just 1 minute, Arnold. And when we talk about history, when we're talking about Git repositories, we're talking about the order of our different commits. And so we have that first commit connected to that second commit, right? And this second commit is, in fact, the more recent one. And the most recent commit that we've made, we call head, as in the head is at the top, right? As in most recent. And we'll talk about branches because now this is sort of a branch and this is all on our main branch, but we'll get there in just a minute. And now if I was to go back to this VS Code source control tool and kind of look at this visual aid, we can see that there's 2 commits here. I can see, in fact, the changes to the file. And this, I think, illustrates some of the power of Git. How I would maybe roll back to this previous version of the file is out of scope for right now. But you can see that this is what Git does, right? It tracks changes to files. And let me just close this out. And let me pause right here because I see a couple questions. Arnold, yes, sir.
So just to verify, so you're not exactly overriding it, you're just updating it and then it just shows on there.
Right. That's a great question. And there's really 2 things going on here. One is the actual files on my computer. like example.txt or example.py. And let's use example.txt as an example. Let me go ahead and change this. So I've modified this file, right? And it's for example.txt, and we're just gonna say change message. If I type git status, we see the changes are untracked. So there's two things happening here. And one is the actual files on my computer. Now, clearly, I've already changed this file. Git's job is to keep track of the changes to these files over time. So Git isn't worrying that the file's already changed. Git's worrying about how is it keeping track of things. And so let's say now I want to tell Git, you know what, this change to example.txt, I'm going to get ready to commit that. So we need to add it first, right? And now it's staged. And now I'm going to commit it. And let's just add a message, and we're just going to say example.txt change message. And now my commit history has three things, right? This was committed, and this is over here. And let's add it as another commit. And again, we haven't really talked about different branches. We're still on the main branch. But now our main branch has three commits. And now the file is still what it is, but Git has the complete history of the changes to this file, along with every other file that we've told it to track and stuff. Does that help answer your question a bit, Arnold? Yeah, great question. Great question. Thank you. I'm not sure what order the hands were in, so I'm just going to go across the screen. Tom, yes, sir.
Yeah, with the one line flag for log, does all that do delete the author and date? Because it looks like the commit hash in the message is still there.
Right. You mean if instead of git log, which prints out the commit history with all this information, I use the git log command with the flag one line. So this is just a condensed version of that commit history, right? A log of my commits. And what I see here on the
okay.
left, yeah, this is not the whole commit hash, the whole like the whole, character number string that uniquely identifies a commit, but it's a part of it. And then I see a part of the commit message. For real world work, companies have standards of how commit messages should look, and a commit, often the title has to be a certain way, and you might even have a couple paragraphs in the commit if it's for something complex. So this is just like a condensed view.
Okay, that's more helpful than I thought, because I was like, if it's just going to delete the author and date, that kind of seems useless because that hash is kind of long.
Right. Yeah, great question. In general, like if a command like log prints stuff, you can be relatively certain that if we add a flag to it, it isn't going to do something unexpected like delete something else. But yeah, it's a good question. Alex, yes, sir.
So how is the computer saving all this history? Is it creating a file for each commit?
Great question. And the answer is yes. And while this is out of scope and stuff that we don't need to worry about, this is what that .git directory, when we created the repository, is for. And inside here, I think it's maybe in the objects directory. Somewhere in here, I'm actually not sure where they put it, off the top of my head. But if we dug around inside this .git directory, we would find all of the individual changes. And then Git can kind of add them all up the same way you'd kind of stack Lego blocks on top of each other to make a building, to sort of like recreate the file. So it is in fact just saving this stuff as files somewhere inside this .git directory.
Oh, okay. Cool. Does that take up can that eat storage?
That's a great question. If you add image files or files that are inherently very big, that can become a problem. With text and code is just text, right? It's not a problem. And all it's saving is the changes, right? If I go to this version control thing and we look at this change message, for this particular commit, it only saves the changes I made to the file. And what it does is it can add these together to get the current state of the file. So each like individual commit is a much smaller chunk because it's just changes. And again, we still have the whole file in our file system here, right? So there's kind of two things going on. I have the actual files, and then inside that .git directory is where the changes are stored, and that's what makes this a Git repository that tracks the history and stuff. Yeah, great question. It's all just files at the end of the day, files of text, which is kind of amazing. Let's see, Cricket, I think you had your hand up. Yes, sir. You might be muted, Cricket, if you had a question. Or let me come back to you. Chris, yes, sir.
Yeah, I think Alex answered one of my questions because I was curious about how the changes were being tracked. Are they being tracked locally, or is it also comparing against, say, the GitHub repo? Because when you commit these changes, is it actually getting published to the GitHub repo? I think I lost your audio.
What about now? Can you all hear me all right?
Okay, I got you now.
Thank you. I hit the mute button on my mic accidentally. Yeah, that's a great question. The short answer is none of these changes have been sent to the GitHub repository in the cloud. There's no automatic syncing at all that happens. Right now, all of these changes, these commits are all just on my computer. In part 2 of the lecture, we'll see how to do this. I have to use explicitly a command, git push. This particular Git repository, because it's not connected to like a GitHub repository in the cloud, because we just created it on my computer, it won't go anywhere. When you clone a repository or fork it from GitHub, it's set up to have what's called a remote. But even then, you have to explicitly use this push command. There's nothing automatic, which is a bit of a pain in the beginning, but ends up being a good thing.
And then one last question is,
Yeah.
I was just curious, when it comes to you're working with distributed teams and you're collaborating on, say, like one file, like we might get into this later on, but I was just curious how that workflow would go if you're working on like one file, or you got people working on different files like .js file, a .py, so on and so forth.
Yeah, that's a great question. The short answer is work needs to be organized so you don't have two people working on the same file at the same time. The long answer was more complex, and there will be a workshop later that tackles it. If two people do touch the same file, it's called a conflict, and there are tools in Git to fix it, but that gets a little more sophisticated. Yeah, great question. Arnold, yes, sir.
Yeah, just to verify, I don't know if I missed it, but how do we access specific logs to open up like a file that we did?
Yeah, great question. Do you mean like if I want to keep working on or editing a file?
Yes.
Yeah, so that touches on a great point. Just because we have this Git repository and this commit history It doesn't actually change how we work with files. I still have these files and they're still normal everyday files. And I can close these windows out. And if I open it up again, like let's open up example.txt in VS Code, it's still there and it's a plain old ordinary file and I can, modify it the normal way. So I think that's the first part of what you're asking. I think the second part was you were saying, hey, we have this commit history that I can see here in the Git log. And I know that each of these commits tracks like a particular change I've made to some files. If I wanted to like go back in time, how would I do that? That is a little more out of scope. The term is checkout. And I would either have to copy a commit hash. I would do like git checkout like this. And I've basically rolled back in time. In fact, if I look at my files and we look at example.txt, it happened kind of quick, but the file actually changed, right? This is the old version of the message. So now this is a little more advanced in terms of like, what do I do with this now that I'm here? If I type git status, it tells us like head detached. So I don't want to go down that road right now because it's a little more complicated. But basically, you can use that checkout command to go back to any previous commit. And this special term head refers to the most recent commit. So again, another way I could do this is git checkout. If I do head -2, I'm telling Git to go back 2 commits from the most recent commit on this branch. And if we do that, we can see that Git has actually messed with the files in my file system. Like these files are still here, but they're empty. We just went back in time, right, to this point. So this is useful. If you kind of paint yourself into a corner with code, it's nice to have this history. We haven't talked about branching and like how to work with this in a practical way, and that's sort of out of scope. So I don't want to get into it right now. If I say git checkout main, Git will just go back to the most recent commit on the main branch, the head, because it still has all of these changes, right? So this kind of takes me back home, so to speak. So again, there's a little extra steps to use it in practice, but that's how you do it, and it does illustrate a little bit of the power of it. Yeah, great question. Rick, yes, sir.
Yeah, so you said it's kind of out of scope, but I guess I'll take that. But I've had issues with coding before where the code worked, I added a bunch of lines, the code broke, and then I went back.
You mean you went back in the Git history to a previous commit?
Yeah.
Yeah, totally. We just haven't talked about branches yet. And so that's why I don't want to go down that road.
Oh, okay. All right.
Yeah. But in fact, that's what's coming up next. Why don't we take a break, guys? Why don't we do, let's see, it's 10:19. How does 10 sound? Should we do a 10-minute break? Yeah. Let's take 10. And when we come back, we are going to talk about branches. So just to kind of recap, we've covered creating a Git repository with Git init. We've seen that a Git repository is really just a directory named .git. And we've seen that, first off, I've got my best friend, the git status command, to see the state of my Git repository. And then the way that I use a Git repository to keep a history of my work is when I change something, it's called untracked, right? Like this change to example py. By the way, if I type git diff, which is short for difference, it will show me the difference between untracked changes and the most recent commit, which can be really useful. And if I decide I'm getting ready to commit this code, first I need to add it, and I can just add all the untracked changes with the dot to add everything in this file, right? And so the workflow is change something, it's untracked, add it, and then commit it. And try to have commit messages that will help you when you look back at your commit history. Right? And now that change, that print statement to example py has been committed and is now in fact the most recent commit on my branch. And if I type git status, we see there's nothing untracked or staged. And if I type git log, I can see the history of my commits, and either on a command line tool, or if you want to use the source control tool for this, you can see the actual granular changes that happen in each commit. In terms of practical workflow, you just want to make lots of little commits as you go. Just get in the habit of doing it. I make a commit like every 2 lines of code. It's just better to make lots of commits and get used to it and get into the habit. All right, on that note, let's break. We'll take 10 minutes. And then when we come back, we will talk about Git branches. And that'll lead into part 2, which is GitHub and a little bit of collaboration workflows. Thank you, everyone, and I'll see you all in 10 minutes. All right. So we covered a lot of ground here, right? We created a repository. We learned how to add work. We learned about the basic workflow of Git, where everything moves through those same stages, right? Where I create code, it's untracked, I add it, it's staged, and then I commit it. And then once my work is committed, it becomes part of the history of a branch. Now let's talk a bit about branches. And let me go ahead and just drag us in TLDraw to where I want us to be for this diagram. All right, that ought to do it. So, branches. The most recent commit I've made, we refer to as the head, as in the head of a branch. A branch is basically how we can deal with having different versions of my code. We saw that when I would kind of check out a previous commit and go back in time, excuse me, that Git would actually change the file, right? If I do git check out the previous commit, let's actually, there we go. Example txt has actually changed. We've gone back to the empty file. And this is just VS Code sort of starter text saying like, hey, put something in here. And if I go back to the head of the main branch, we have our message. With different branches, it sort of takes this to the next level. So first, let's see how to create a branch, and then we'll kind of see it in action, and I think that will help illustrate it. The command to create a branch is a little awkward. We have to use this checkout command and give a -b flag, B for branch. Full disclosure, the Git command line interface is a little wonky. That's pretty much universally acknowledged. After the -b flag, we give the name of the branch we want to create. And Git tells me I've now switched to a new branch named myFeature. If I type git status, we see that we're on branch myFeature. If I want to go back to a different branch, first I can do the command git branch will show the different branches that exist. That's what I was reaching for there. And which branch we're currently on. And we can see that we're currently on myFeature. And if I want to switch or check out another branch, I use the checkout command and I give the branch name. And so I can go back to my main branch. Right now, these two branches are exactly the same. There's no difference. Let's change that and add something to the myFeature branch that doesn't exist on the main branch. So let's go ahead and let's open up our Python file and let's add a message here. Let's say print goodbye moon. And if I look at the JavaScript file, we never put anything in here. So let's add console log goodbye moon. And just for fun, in the text file, let's add another message here as well. And if I type git status now, we see that we're on the myFeature branch. I've made a bunch of changes that are unstaged. I can use the git diff command to see the difference between all of the unstaged changes and what's committed. And we see here our new stuff in green. I'm just going to go ahead and add the changes I made to all of those files. And now let's go ahead and make this commit. And we'll call this add goodbye messages to all files. And now if I type git status, we see we're on the myFeature branch and the working tree is clean. And if I type git log, I see something really interesting. I actually see all that commit history from the main branch, as well as this goodbye message. And this is kind of interesting. And if I open up our sort of source control sidebar and this graph, you can kind of see here, let's look at the myFeature branch. And we can see that when I created the myFeature branch, it used all the previous work, right? It branched off of the main branch. And that's why you hear this term branches, because think about, say, branches of a tree. And so now we have this new commit, and I'm just going to copy this just so to make life easier. So I'm just going to call it goodbye message. And it's on this other branch. Right? And so I have two branches. I have main and I have myFeature. But because I created myFeature off of main, it has all of this as part of its history. And head now points to the most recent commit on the myFeature branch because this is the branch that we currently have checked out. And let me go ahead and adjust my screens for just a minute. Just bear with me here. And let's do a couple splits. And let's do one more split. And let's look at example PY over here. And example JS over here. So I can now see all three of my files at once. And let's watch what happens when I switch branches and check out the main branch and switch back from my feature to main. That goodbye message that I added to all three of those files is gone, right? Because when we made that commit, we did it on a different branch. And so when I check out a branch under the hood in that .git directory, Git is keeping track of the most recent commit on each branch, and it switches the head to the most recent commit for the branch. And so here we can see Git really does modify our files in the file system. And if I want to try out different versions of my code base, branching is a great way to do it. Maybe my code is working, but I want to try to add a new feature, but it's Saturday night and I'm tired and I'm worried I might introduce a bug. Well, I can have the main branch that has the good, safe, stable version of my code, and I can check out and create off of that main branch of my feature branch where I still have all that work. I can do whatever I want. We'll talk about how to combine branches later, but if I run into trouble and I introduce a bug or I decide this is not a good idea, I can just switch back to my main branch. So that's the power of branching, right? And to just kind of expand on this a little bit, let's check out the my feature branch again, and let's add another message to one of these files. Let's just add something to the example JS file because it's a little small, right? It's a little lonely. So let's just add a console log that says more goodbye. And if I do git status, we see that's the change. Let's go ahead and add it. Let's commit and let's say example.js, more goodbye. If I do git log, we see that that's there, right? So now what has happened is, we're on my feature, excuse me. I've made another commit, right? This one is more goodbye. That's the most recent commit on the branch. So that's the head of the my feature branch. And now if I switch back to the main branch, we lose both of those, right? Because that work was on the other branch. So I just want to pause here and see what questions folks have or what people are curious about. Cricket, yes, sir.
So whatever you update, so it's gonna move the branches, the last stage to commit from the dragging from the main file.
Yeah, I think that's correct. Like if I'm understanding your question correctly, it depends which branch I'm working on, right? When I'm working on my feature, any commit I add or create is done on this branch. If I've switched over to the main branch though, any work I add is done, and I apologize, I need to turn off my autocomplete here, on this branch. So for instance, right now, I'm on the main branch, right? If I type git status, you see I'm on branch main. I'm modifying example.js. Let's go ahead and add it to stage that change. And let's commit that change. And we'll say example.js hello. And so now I've created another commit on my main branch. We'll just call it like more hello. And that's now the head of my main branch. That's for example.js. And if I switch from my main branch, which I'm on right now, to the my feature branch, the my feature branch does not have that commit. So this change, this work that I saved in that commit, again, it's like you put a cookie on a baking tray in the oven and you bake it, it's committed. Right? That work is not there, but we have the other work.
Okay.
Does that help answer your question?
Yes, sir. Thank you.
Yeah, great question. Thank you. Chris, yes, sir.
I guess from my understanding, it looks like if you create a new branch, then say you're working up a solution or something, you can always go back to the main if you wanted to scrap that branch.
Your audio was cutting in and out again. Say that again.
So I guess from my understanding, you can always, like if you're working on a solution on a new branch and it doesn't work out, you can always move back to the main branch and create a new branch.
Exactly.
Scrap the old one.
Exactly. And even better, you don't even lose the old one. It's still there. Right? When I switch back and forth between branches, nothing is lost. Right? It's kind of weird because Git is indeed changing these files. But remember this .git directory. Every single change I've committed for all of my branches is in here. And it's never going to be deleted unless I do something dangerous and unsafe, which is more advanced than we're not going to learn about, and you would rarely do. So that's the beauty, is I can have all of my changes and all my work and organize it. And indeed, I decide, you know what, I don't like that my feature branch. I'll just go back to the main branch. And later, if I change my mind, you know, that other work is still there on the other branch.
Well, how would you say how would you scrap a branch or get rid of it if then?
Yeah, that's a great question. You can delete a
actually-
branch. I think the command is git branch -d. The short answer is for now, don't. There's no reason you're going to end up deleting something you don't want. It barely takes up any space. It's way better just to have them. Yeah, yeah, great question. Arnold, yes, sir.
Yes.
So just to verify, whenever you create a branch, it basically copies all the files from the main branch. And then you can work on that. If you don't save it or merge it, it doesn't reflect on the main branch.
Yes, you have it correct in terms of the behavior. When I make a new branch, it depends where I start. If I'm on my feature and I do git checkout -b, you know, branch off my feature, it's getting a little fancy now, right? I might, all the work I do for like this new branch, which will make green, would be over here. But there's a connection, like each commit knows the one that came before. And in practice, this is getting too complicated. The pattern almost everyone does is you just make branches off of the main branch. And the only thing I would add to what you're saying is it doesn't even have to copy the main branch. It just, we already have each of these individual changes. It just keeps track of which one came before. Each change knows its parent, right? It actually is kind of like everything points back like this. So when I make a new branch, it just needs to point back and we have all these changes there. But in essence, in terms of how we use it and the behavior, you're bang on, and that's correct. Does that help a bit? Yeah, great question. Tony, yes, sir.
Yeah, just real quick. So do you advise moving everything that's finished back to the main branch just to keep it organized, like as a standard, or do you just keep all these branches out there willy-nilly?
That's a great question. When you are collaborating with other people, you generally, when you're working on a feature, you create a branch named like Adam's feature or, you know, add login off of the main branch. On a practical level, for the introductory assignments and the assignments in OOP, just do everything on the main branch. It's going to make life way easier. The only reason to use other branches right now is if you want to experiment with something and you don't want to mess up main. We are going to do some practice exercises with branches and merging and stuff, but especially because right now you all will just be solo developing, it's going to be easier to just do all the work on main. And when we get to group projects and things like that, is when we'll actually use feature branches and merging and stuff like that. Yeah, good question. Right now, on a practical level, branches are good for experiments, so you don't mess up your code that's already working. And if you feel a need to like back something up for any reason. What other questions do folks have, or what's on people's minds? Alex, yes, sir.
Yeah, so every branch is gonna have a head, right?
Yes. So you could, if you want to, you could imagine under the hood, it keeps track of the head of each branch. But then there's sort of like, it uses a different word for it. But then there's sort of like the main head. Like, and when you check out a branch, when you use head, it's referring to the head of the currently checked out branch, right? So if I'm working on my feature, head is here. If I'm working on main, head is here. But under the hood, Git is keeping track of it for each branch. Yeah, great question. Great question. All right, Sam, and then let's move on because I want to talk about merging. Okay, and Ryan. Sam, yes, sir.
Yeah, if you have multiple files like in the staged area, but you only want to commit one of them, is there a way to do that? Or when you commit, are you always committing everything that's staged?
Great question. When you commit, you are always committing everything that's staged, but let's see how to unstage something. So if I type git status, I see here I have this unstaged change foo. I'm just going to use one thing for example purposes now. Let's go ahead and add it. And we see here this staged. Git gives us a hint here. There's this command git restore staged. And let's actually just open up example.py. And let's go ahead and let's also print something there. And let's add that to the mix as well. So now I've got two changes to two separate files staged. And if I decide I want to unstage one of these changes, I can use this command here, which is git restore -- stage, and then the file name. So here I do need to be specific. And this does not modify the file. Note that that change is still there. But if I type git status, I see that what's been staged and ready to be committed is just the Python file. So that's how you would do that. Yeah, great question. Ryan, yes, sir. And then I do want to move on to branching.
Just real quick for the git commit -m, when you're naming something there, that's just for like, I mean, that's just for your record. You don't have to be specific on what your changes were to the commitment, right?
That's a good question. I think the answer is you do want to be specific because when you join a software engineering team, that team will probably have a standard around what commit messages look like. And in fact, let's go to like a big open source project. And I think that will help. Now, on a practical level, when you guys are learning this, just keep the messages simple. Sometimes half of my git commit messages are WIP, which is short for work in progress. Sometimes my commit messages are finally I fixed it. But if we look at a commit history here for React.js, right, which is a big front-end framework that we'll learn later in the course, and we look at the commits here, we can see these are actually highly organized. It says what kind of task it is. It says what it's for. And in fact, if we go to the commit, we'll see here, well, that commit message is pretty short. It's often in the pull requests where they have more information. Let's see if they have more here. Here we go. So this commit message is pretty specific, right? So when you're on a team and dealing with a big code base, the commit messages really matter, and different teams will have different standards. So right now, just get in the practice of making lots of commits. In a perfect world, a commit should should be like a working chunk of code. Like if I get a function working, that'll be a commit. If I make one change to a function, that'll be a commit. Just keep the messages short and just try to have them be descriptive. But just to give you guys kind of a heads up of down the line where this is going. Does that make sense? Yeah, great question. Great question. Again, I don't want you guys to worry too much about, is my commit message good or is my commit message bad? I want you all to be making commits and adding simple messages to them, so that when you type git log, it makes some sort of sense to you. Yeah, great question. All right, let's talk about merging. And this is kind of the last piece of the puzzle. We've gone through branching. We in fact have a couple different branches. We in fact might have a bit of a challenge here because I've actually added, my main branch has gone on a bit ahead. Now that I've done this work on my feature, I've decided it's time to merge this to the main branch. I like my experiment. I want to pull it into my main code base. So the command is relatively straightforward. It's git merge and the name of the branch. And as it sort of indicates here, it just sort of like connects the dots, so to speak. We might have a little bit of complication here because I've added this main branch that's sort of forged on ahead a bit. So let's try this and see what happens. And when you merge, you always merge from one branch to another. Right? So what we're about to do, we would say, I'm going to merge my feature onto main. Or pull my feature onto main. So I'm going to check out, oh, what did we do here? My apologies. I just got rid of a change I didn't want. And indeed, we see here Git is actually kind of keeping me. This is actually a great example of the value of staging a file. Right? I'm not sure where that guy came in there, but I have this change staged and I'm trying to switch to another branch, and Git says, no, 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 no. You put the cookie on the baking tray. You need to tell me what to do with it. So we're just going to say added something to example UI, just so I can get back to main. And so now I'm on main, right? There's the my feature branch. So I want to merge this my feature branch onto main. So main is what we call the base branch for a merge, and my feature is what we call the target, right? And we're gonna bring the target onto the base. So I'm going to make sure I'm on the branch I want to be. I'm on the main branch. I'm going to do git merge my feature, which should bring the changes from my feature onto this branch. Now, this is a little bit more of a complicated situation. You guys usually won't encounter this early on. This is because we did that extra work on main after branching to my feature. And this is what's called a conflict. This is a little more advanced. You all won't need to worry about this too much right now. So I don't want you to stress out about this part too much. Basically, Git is saying, hey, the same line of code has been changed by different commits. And I'm not going to try and be clever and figure out which version is the right one. I need you, the human, to tell me. So in VS Code, what we have here is we have in the middle where we're going to end up. On the left is the my feature branch. Here it's called incoming, right? Or target. And then on the right, we have the main branch. And again, this is more advanced. I don't want you guys to worry about this too much. The interface can be a little bit confusing. We can see here that we added this goodbye moon message and this more goodbye message on my feature branch. And on the main branch, we added hello world. So I, as the programmer, have to decide which of these I want. I could accept just one. I could accept just this one. I could accept all of them. In fact, if I wanted to, I could even copy some of the code over, or I could modify this file. And in fact, I think I just want everything. And indeed, I made an error there, so let's fix that. And now that this is fixed, I think it's looking right. Let's hit complete merge and let's see if that does the trick. Now, if I type git status, we see all conflicts fixed. I'm still merging. Use git commit to conclude the merge. We're going to create a merge commit here. So we're going to do git commit. Because I didn't add the -m flag, the commit message comes up here. I'm just going to use the default message here that says we're merging the branch my feature. I'll uncomment this so we can see where the conflict was in case it's an issue. I'll save it, I'll quit it, and now I'll type git status. And now if I type git log, on main branch, we have this merge commit. And we have the changes from my feature branch and the main branch. And so here, now our graph is getting a little interesting. And we can kind of see here, like on the main branch, that we had in blue all this work we did on the main branch, right? Then we switched over to my feature and we did these two. But I switched back to main and I did this one, and that's what caused the conflict. And again, you guys are not going to run into conflicts and don't have to worry about them right now. And then we have the merge commit that brings it all together. And so now I've merged my feature branch back onto my main branch, and it looks roughly, something like this, where I now have basically a merge commit. That points back. Now I still have the feature branch. It's not gone, right? But now main also has that work in its history. So I realized I got a little in the weeds there with stuff and the diagrams jumped around a lot. So I just want to pause and check in and see what questions folks have and what might be good to cover. Alex, yes, sir. Yeah, I saw you had a question.
Okay, so to merge, it's git merge and then the branch name.
Yep.
And this merges the name branch to the branch that you're on.
Exactly.
Got it.
Yeah, exactly. My scenario got a little complicated because we did extra work, but most of the time it will be simpler. So,
Okay.
yeah, so I'm on main branch. I have work I've done on some other branch that I want to bring onto the main branch. So I say git, I want to merge the work I've done on my feature branch here to main, here to the branch I'm currently on.
Okay. And are you allowed to merge branches to say main if it didn't branch off from main?
You can merge any branch you want. I will say, because main is by definition the very first branch that is created, every single branch you create is somehow going to go back to main, right? Like if we kind of draw a diagram here, if this is main, I might branch off of it over here, and maybe I even branch off of it over here, and maybe someone branches off on another branch or another branch, and maybe this one's over here. But main is still the root of the tree, right? It's where everything else starts. But you can merge any two branches you want.
Okay, and you don't have to go back individually. Like you don't have to branch, say that third branch to the one before it, and then up and up until you get to main.
You do not.
Got it.
Yeah. Again, in practice, you want to keep it simple. Most people just branch off of main. You usually don't see branches off of branches off of branches, or if you do, it's in a much larger team situation. And definitely outside the scope of what we're looking at now. Arnold, yes, sir.
Yeah, so just to go with what Alex says, so does that mean naming your branches in a specific way helps?
It's good to have a naming convention for your branches to help keep track of them. For us, it doesn't have any real impact on the merging itself.
So what would happen if you have like two branches of the same name?
I don't think that's allowed. I don't think Git would say you can't create that branch with that name when it already exists. Yeah, good question. Tom, yes, sir.
Is there any special considerations that the main branch gets that the others won't? Such in the case that, say, this is a very long-standing program and somewhere along the line, a very catastrophic bug was introduced into main and just now reared its head years later, and we need to fork off. We've created a new branch, we've somehow fixed many issues, but it's just a cluster and we need to establish like a new main. Is that something we can do, or is it just going to be something that, like, as a company we can just say, from now on just use new main as the main from now on?
Yeah, that's a good question, right? I think what you're asking is how do you manage the complexity of this if there are problems, and how much does Git do for you versus how much do we do for ourselves? The short answer is we have to manage it ourselves. Software engineering teams have really strict processes that control when things get merged. Like junior engineers aren't allowed to merge stuff without it being reviewed by like senior engineers. And not in Git, but in GitHub, you can set rules so that like a branch can't be merged until it passes all the tests, and a branch can't be merged until it's been approved by other people, and that you can't like directly change main. You have to do it through a branch. So there's a whole bunch of both like team processes and in GitHub controls in place to manage and control this. But at the end of the day, that's the job of the software engineering team. Chris, yes, sir.
Yeah, I was just thinking if there's multiple branches being made, say for instance, you have the main branch, then I create a branch off the main, and then say Arnold creates a branch off my branch. Let's say what happens if my branch, like what happens if I delete my branch when Arnold has a branch off mine?
You should make sure you talk to Arnold before you do that.
Would that any branch following mine, would that also be removed?
No. So that's a good question. If you delete a branch, I don't think it would delete the other branches. Like the history is still there, so you can have like backups that way. Yeah, once something is committed, it's not really lost. again, you guys should not be deleting branches. You are gonna end up getting into trouble. There are better ways to solve those problems. These are really good questions around sort of managing multiple branches and around collaboration. Big picture, though, the answer is keep it simple. And we're going to have some Beyond Tech talks on this, but this is why like how teams collaborate and communicate is such a big deal in software engineering. Because when you're on a team of 5 or 6 people, you can't just go around willy-nilly doing stuff, right? There has to be a process. And I think that kind of cuts to the heart of what you're asking. Like, yes, Git has protections, but like these tools, they have some guardrails for us, but by definition, like our job is to learn like the expertise to be able to use them well. And this is just the beginning of that journey, right? This is like day one of Git. The stuff with like branches off of branches is honestly a much more sophisticated scenario. Yeah, great question. And again, like if you have stuff committed on one branch and someone deletes another branch, and the branch, like the commits are still there. Yeah, great questions, guys. I know I'm kind of sort of repeating ad hominem, like keep it simple and people need to communicate. But that's sort of the truth of it, right? And I think big picture, the thing to remember is software is complex enough by itself. Some complexity is necessary and comes as part of the learning process. Otherwise, though, our job is not to introduce unnecessary complexity. Let's wrap up here and take a break so we can talk about GitHub and collaboration, which will also touch on some of these questions. So we've been working with the GitHub locally. We're going to see how to connect to GitHub in part 2 of the lecture, and we'll see a little bit about collaboration. We also have here a cheat sheet with some of these Git commands. That's useful. We also have some general advice here. I think this is the big one. Never use a Git command you don't know exactly what it's doing, and ask for help sooner rather than later. With coding, a lot of times you can like move fast and break stuff, as they say. With Git, you can really get yourself into trouble, right? You can make stuff a big spaghetti mess, or you can delete something you didn't mean to by running too complicated of a Git command. If you're not 100% on what a command that you're going to do in Git does or how to solve something, reach out to a TA or Francisco or myself. This is like the one area where you don't want to kind of just like guess and check, because it can become a real problem. We also have linked here a series. It's sort of a more advanced cheat sheet that walks through a number of different things, which I think will be quite useful. So I just want to point that out too. All right, guys, why don't we break? Let me go ahead and stop the recording.